Okay, so now you're at 4.4, which is investigating the sine law. Now, just to refresh your memory, the sine law states the relationship between the sine of the angles and the ratio of the opposite sides. Okay? Now, the sine law, you can use it if you have two angles and a side in front of one of the angles, or two sides and the angle in front of one of the sides. So that's the condition for using sine law. Two angles and a side in front of one of the angles, or two sides and an angle in front of one of the sides. Other than that, you cannot use sine law. You can go ahead and use sine law, but you will see that you will have more than one unknown in one equation, and there is no way to solve that one. So the question that now comes to your mind is, how can I use sine law? Now, the formula that was presented to you before, okay, is the following. Any side, for instance, side A, divided by sine of the angle in front of it, so side A divided by sine A, is equal to another side divided by sine of the angle in front of it, so C divided by sine C, and B, the side B, divided by sine of the angle in front of it. So it's very straightforward formula to use. You have three ratios, three fractions which are equal to each other. Now, the question is that, do you have to use all these ratios together? No. You will end up only using two of them. For instance, you use sine A over A equals sine B over B. Now, the first one, as you can see, is one form. If I flip all these fractions, you can see that sine A comes up, A goes down, sine B goes in the numerator, B goes in the denominator, sine C goes in the numerator, B goes in the denominator. If I flip all the fractions, I get the second form of sine law, which you can see right there. Now, the question that is going to come to your mind is that when am I going to use the first one or the second one? Depending on the type of the problem, again, and your taste, you can either use the first version or the second version. Both of them are going to give you the same answer. Okay, question number 1. It says, if I have a triangle RPQ with angle R to be 74 degrees, angle Q to be 63 degrees, and side PQ to be 12.7 centimeter, find side Q. So go ahead, see if you can solve this one. Okay, in this problem, I have to find Q, okay, which is here. Now, I know the angle in front of it is 63, and I know angle 74 and side 12.7. So I can use the sine law. I can say that 12.7 divided by sine 74 is equal to Q, because I don't know what the side is, divided by sine 63. Now I'm going to cross multiply, so this times this and this times this. I'm going to get Q sine 74 is equal to 12.7 sine 63. Then to isolate Q, I'm going to divide by sine 74. Sine 74 is canceling out with sine 74. So Q is 12.7 sine 63 divided by sine 74, which is going to give you approximately 11.8 centimeter. This problem, you have a triangle One side is 13, the other one is 12, and the angle E is 48. The first thing comes to your mind is, can I use sine law? The thing is that yes, you can use it because you have angle 48 and the side in front of it. Remember that the condition to use sine law is that if you have two sides and one angle which is in front of one of the sides. Now I have 12 centimeter and also 13 centimeter, and angle 48 is in front of 12 centimeters, so it tells me that I can use sine law. So to use sine law, I'm going to write the following ratio. I'm going to say 12 divided by sine 48 is equal to 13 divided by sine f. Now I'm going to cross multiply. I'm going to get 12 sine f is equal to 13 sine 48. Now I'm going to divide by 12 to isolate sine f. And I get sine f is equal to 13 sine 48 divided by 12. Now, if you use the second function on your calculator for the inverse sine, you will find that f is approximately 53.8 degrees. Okay, example 3, we have a weather balloon which is sighted between two observation points. From one observation point, the angle of elevation to the weather balloon is 65, and from the second one is 37.4 kilometers away, and the angle of elevation is 43. The question is that what is the distance from the observation point to the balloon? So go ahead and see if you can solve it. Okay, so now you have two observation points A and B, which I drew there, and a balloon which is at point C. The angle of elevation from observation A is 65, from observation B is 43, and the distance between A and B is 37.4 kilometers. I have to find the distance AC and BC. To do that one, and to use the sine law, I need to have two angles and a side in front of it, or two sides and an angle in front of one of them. To do this one, to use the sine law, I'm going to find angle C first. To find angle C, I'm going to say the sum of the angles is 180. So I can say angle C is going to be 180 minus 65 minus 43, which is going to be equal to 72. Thank you. Now, I know angle C is 72. Now I can use the fact that I have two angles and a side in front of one of the angles. I can use the sine law. So let's write the sine law for side AC. So I can say that AC divided by sine 43 is equal to 37.4 divided by sine C, which is 72. Now I'm going to crisscross. So I'm going to get AC sine 72 is equal to 37.4 sine 43 divide by sine 72, and you are going to get AC is equal to approximately 24.9.
Why didn't get that?
So the answer that I wrote here is incorrect. It's 26.8 meters. Kilometers, sorry. Now I have to find CB. So to find CB, I'm going to use the sine ratio again. So this time I'm going to write CB divided by sine 65 is equal to 37.4 divided by, and what was the angle for C? For angle C? 72. So I can write sine 72. Again, I'm going to crisscross. I'm going to get CB times sine 72 is 37.4 times sine 65. And I'm going to divide by sine 72. And I'm going to get CB is approximately, how much? 35.6? Is everybody okay? Beautiful. So everything is okay now.